Again, welcome back to Unit 7, Part 3 lectures. In these lectures, we're going to cover the hypothesis testing for the mean. So our main objective is to learn how to find the critical values in a t-distribution, also how to use the t-test to test a mean or population mean. Now, this lectures is the same concept as our previous lectures, which is the z-test. Here we are doing hypothesis testing using the t-test method. Previous lectures, we learned how to use the z-test. Normally, the z-test, one of the main conditions is if we know the standard deviation of the population. Now, if we don't know the standard deviation of the population, then we can use the t-test. Both z-test and t-test are parametric testing, and we can test the mean. Now, we have three different types of t-tests. For example, we have the per sample t-test, which means we have two samples, two different group of samples that came from the same population, and the size of the two samples are the same. And we are going to, again, test their mean. And we also have one sample t-test, which is the same as the z-test, only one sample. Then we have a dependent sample, which means we have two group of samples, but the size can be different, and also they can come from different population. So let's start with the t-testing. Here we said to find the critical values in a t-distribution, first we need to identify the level of significance, which is the alpha. Then we can identify the degree of freedom. So this is the difference between the z-test and t-test. In z-test, we don't find the degree of freedoms, but in t-test, we have to identify the degree of freedom. The degree of freedom is in the table. So for example, if I'm going to look for a critical value, I need to know the degree of freedom, which is normally the sample size minus 1. And that will give me the value of the row on the row section to go on the table. So after that, if we know the level of significance, we know the degree of freedom, then we can find the critical value using table B. Now, table 5 in appendix B is the t-distribution table. So again, if you are using different textbook, it may be in different page, or the number of the table will be different, but this table is the t-testing or t-distribution table. So we also have the same number of hypothesis tests. Same as z-test, we have the left tail, we also have the right tail, and we also have the two tail. So the same concept. So now we have one example here. They say we should find the critical value TO for a left tail test given alpha equal to 0.05 and n is equal to 21. So we know the value of alpha, we know the value of n, so we can find the degree of freedom, which will be n minus 1, which is 20. So this means we have to go to the row 20. So we look at the 0.05 in the one tail alpha column, and the row will be 20. So here, when we look at it, again, we have the value given to us. So because the test is a left tail test, the critical value is negative, which will be negative 1.725. Again, to get this value, we go to the t-test or t-distribution table. The row is always the degree of freedom, which is 20. And then on the column, we look for, again, 0.05, which will be one tail 0.05, because we are doing left tail test. Now, next question says we should find the critical value TO and negative TO. And this time we have two tail tests. So we should have a positive and negative value of the critical values. So alpha is given to us again. We know the sample size, so we can find the degree of freedom, which is n minus 1. So that gives us 26 minus 1, and that gives us 25. Then we go to the table. We look at 0.05 for alpha, but this time in the two-tail alpha column. Then our row is 25. So this gives us negative 2.060 and also positive 2.060 is a two-tail. Next, we will go through how we can test and the mean using t-test. So here we have t-test for a mean population, that's population mean if n is less than 30 or the standard deviation is unknown. So those are the two conditions. Remember, in a z-test, the sample population must be at least 30 or more. So if the sample population is less than 30, then our next option is to do t-test. We can't do the z-test with a sample less than 30. And also, if the standard deviation of the population is not known, we don't know it, then we have to do t-test. In order to do a z-test, we have to know the standard deviation of the population, and also the sample size must be 30 or more. So those are the two conditions given here. In order to do t-test, sample size is less than 30. We also don't know the standard deviation of the population. So that's the step for t-test for the mean. First, we say it's a stat test for a population mean, same as z-test. But t-test can be used when the population is normal or nearly normal, and the population standard deviation is unknown, and also the sample is less than 30. If the population standard is unknown and the sample size is less than 30, we cannot use z-test. So here we say the test statistics is a sample mean, same as the z-test. But here we have different formulas. The standard test statistics for t is the x bar minus mu over, again, we are using s, which is not the population, but rather we are using the sample standard deviation divided by square root of n. Then we also have to find the degree of freedom, which is the sample size minus 1. So these are the steps in words and also in symbols. So first we state the claim mathematically and verbally. Then we identify the null and also the alternative hypothesis. So here we state HO and HA. Next, we need to specify the level of significance, which is the alpha value. Then the next step, we need to identify the degree of freedom, and we sketch the sampling distribution. Then we determine any critical values using the table 5 in Appendix B. Again, it depends on your textbook. It can be any table number, it can be any appendix. But again, this is the T distribution table. Next, we determine the rejection region, if there's any. Then we find the standardized test statistics using the formula T equal to x bar minus mu over s divided by square root of n. Then we're going to make a decision based on the critical value and also the p-value. So we make a decision whether to reject or fail to reject the null hypothesis. Now, if the T is in the rejection region, then we reject HO. Otherwise, we will fail to reject HO. Then we're going to interpret our result or the decision in the context of our original claim. So let's see an example here. Here they say a car or a used car dealer says that the mean price of a 2005 Honda Pilot LX is at least 23,900. You suspect this claim is incorrect, and you found that a random sample of 14 similar vehicles has a mean price of 23,000 and also a standard deviation of 1,113. Is there evidence or enough evidence to reject the dealer's claim at alpha equal to 0.05? Here we are assuming the population is normally distributed. So first, as usual, we state our HO and HA. So we say greater than or equal to 23,900 or less than 23,900. Next, we know the alpha value is given to us to be 0.05. Degree of freedom depends on the sample size. The sample size is 14, so it's 14 minus 1, which is 30. Then next we plot our graph. We have the alpha value, we have the degree of freedom. We can find the critical value, which is negative 1.771 from our T distribution table. Then after that, we do our test statistics using the formula X bar minus mu divided by S divided by square root of N. And that gives us 3.026. Now we are going to make our decision to reject HO. The reason why, because again, we can see 3.026 fall around the brown area. So this is for the reject region. So we say at the 0.05 level of significance, there is enough evidence to reject the claim that the mean price of 2005 pilot LX is at least $23,900. Let's see second example. So here they say an industrial company claims that the mean pH level of the water in a nearby river is 6.8. So that would be our claim. You normally select 19 water samples. So the sample size is 19. And we measure the pH of each. Now the sample mean and standard deviation are 6.7 and 0.24 respectively. Now, is there enough evidence to reject the company's claim at alpha equal to 0.05? Here we are assuming the population is normally distributed. So first we state our HO and HA. From the question, we said the claim is 6.8. So if it's equal to 6.8, then we are going to do two-tail. Here they say the water is nearby river is 6.8. So we have 6.8 and not equal to 6.8. Alpha is given 0.05. We know the sample size is 19, so we say 19 minus 1 will give us 18. Then we know the alpha value 0.05. We know the degree of freedom. We can find the T value or T stress. So here, looking at the table, we get negative 2.101. But remember, we are doing two-tail test. So we go to the right and get the same 2.101. So now we can find the test statistics, which is X bar minus mu over S divided by square root of N. So we plug in all the values and the answer is negative 1.816. Now, negative 1.816 will fall under the brown area. It's not inside the blue. So this means we are going to accept HO. So we fail to reject HO. When it's in the blue area, then we accept HO. So here we say at the level of 0.05 significance, there's not enough evidence to reject the claim that the mean pH is 6.8. Another third example given, here we say an American Automobile Association claimed that the mean daily meal cost for a family of 4 travel on vacation in Florida is the claim given as $118. But we take a random sample of 11, which means N is equal to 11. Such families has a mean daily meal cost of $128 with a standard deviation of 20. Is there enough evidence to reject a claim at alpha equal to 0.10, assuming the population is normally distributed? So here we state our HO and HA. The meal is $118 or not $118. So here we are using technology system with the calculator T18384 setup. So we input our data in, and then we calculate our t-test. Then we came up with a draw. Again, this is a two-way, or two-tail. So we have it. So the decision will be if 0.1664 is greater than 0.10, the alpha here is given to us to be 0.10, 10%. So here we say if it's greater than 0.10, then we are going to fail to reject the age. Since the value is 0.1, the test start is again greater than alpha value. So that will be the conclusion of these lectures. Again, in these lectures, we learn how to find the critical values in a t-distribution, and also how to use the t-test to test a mean, population mean. The concept here again is the same as z-test. The only thing we have to meet some condition with the z-test, as we said earlier, we need to know the standard deviation of the population, which is one of the most important value. Now, with the t-test, we don't have to know the standard deviation of the population. So again, wish everybody the best and thank you for your time.